Hey guys, welcome back to General Chemistry. This video is going to serve as an example for determining number of significant figures. So real quick, let's just go over our rules of sig figs and then let's take a look at some examples. So the first rules are going to cover numbers that are always significant. So any non-zero digits are always significant. So zeros are where things kind of get tricky. So all non-zero digits are significant. Any captive or interior zeros are going to be significant. So if there's a non-zero digit on either side of the zero, that would be an interior zero and it would be significant. And then any trailing zeros, so after a decimal, after a number, trailing zeros will always be significant. What are not significant? Well, any leading zero. So if the first number that you come across is a zero, that's going to be not significant. And those are easy to clean up with scientific notation. And then trailing zeros without a decimal are tricky. So here is a list of examples. So what I want you guys to do is listen to the directions, pause the video, and work them out. So first, going through from A through G, I want you guys to determine how many significant figures are in each of these numbers. If there is an asterisk or star next to them, I want you guys to practice going from standard notation to scientific or back the other way. So if there's an asterisk next to it, go ahead and put it into scientific notation. If it's in scientific notation, take it out of scientific notation and put it into standard form. So go ahead and pause the video, work these out, and then I'll work them out with you. All right, so now that you've worked them out, let's go through them together. So for A, how many significant figures do we have? So for A, we've got 2 significant figures. So let me write that out here, 2 sig figs. So this goes under the leading zero category. So the first number that we come into contact is a 0. So all of these zeros are simply placeholders. They're not actually significant values. The only 2 values that are significant are the 3 and the 5. For this one, I also asked you to put it into scientific notation. And when you do this, you'll see that the sig figs clear up pretty quickly. So to put this into scientific notation, I'm going to move the decimal until I have a number between 1 and 10. So 3.5 times 10. And then I'm going to tell the viewer how many places I moved it. 1, 2, 3. And then this number was originally less than 1, so that's how I know this exponent is going to be negative. Now that we put it into scientific notation, it's very clear that only the 3 and the 5 are significant. What about B? So how many sig figs do we have for B? There are 4 sig figs. Okay. Why is that? So again, the zeros are always where things get tricky, right? So this first 0 here is an interior 0. There's a 1 and an 8 on either side of it, so that makes it interior. This last 0 falls under the category of after a decimal, after a number. So after a decimal, after a number, that 0 is significant. Kind of the silly way that I remember this after a decimal, after a number, I always joke that chemists are lazy, right? We use symbols to represent anything and everything. So if I bothered to write a decimal, I bothered to write a 0 and an 8, and then I bothered to write another 0 after that, I did that for a reason. I'm not going to just write a 0 for funsies. So that last 0 was put there for a reason, and it's because it's significant. Right? Letter C, how many sig figs here? Well, this one's a pretty easy one, right? This one has 4. All of these are non-zero digits, so all of them are significant. Letter D, so this one is in scientific notation already, so that makes the sig figs really easy. This one's got 3 significant figures. So only the decimal portion of this is significant. The exponent piece over here is simply a placeholder, so it's telling us about the magnitude of that number. So only the first 3 digits are significant. I also asked you guys to write this one into standard notation, so taking it out of scientific notation. So first thing I see here is my exponent is a negative number. So when I move this decimal, it's going to be smaller than 1. It's going to be a number that's less than 1. And then that 3 tells me I have to move the decimal over 3 places. So standard notation is going to look, like this. So the decimal was here, we moved it over 1, 2, 3. Cool. All right, letter E. This one's tricky. So trust that I'm not going to be this mean on an exam, but I put it on here because it makes a great teachable, talkable moment. So for letter E, how many sig figs do we have? Infinite or unlimited? So why is that? So this is an example of a definition. So definitions are counting numbers. So by definition, 1 dozen equals the exact same thing as 12. So that would be a counting number. It's unlimited sig figs. This is going to be important when we get to doing unit conversions. The fact that definitions do not change or limit our sig figs is going to be really important to us. But this is a definition. It's a counting number, so unlimited sig figs. All right, letter F. How many sig figs do we have here? We've got 5 sig figs. So this again is an example of a number, or excuse me, a 0 after a decimal, after a number. So here's our decimal, here's our number, and these 2 zeros reside after that. So every single one of these zeros is significant. I asked you guys to put this into scientific notation, and I'm guessing this is what you did. Okay. That is not correct. How many significant figures are in the number that I just wrote down? Yeah, there's 2. How many significant figures did I say were in this number here? Yeah, there's 5. When we write things from standard notation to scientific or vice versa, we cannot lose any of those digits. If we claim that they're significant in standard notation, we have to maintain the same number of significant figures when we put it into scientific notation. So the correct way to do this in scientific notation is as follows. Okay. Now we've maintained 5 significant figures while putting it into scientific notation. Does that look really silly? Well, of course it does. If I were reporting this number, I'd probably keep it in standard notation. But I told you guys you had to put it into scientific notation. So if you had to put it into scientific notation, this is what it would look like. That might change some answers for the next one. So how many significant figures do we have here for G? We've got 3 sig figs. Okay. So again, this 0 is after a number, after a decimal. So all 3 of these digits are significant. And then I asked you to put this into scientific notation. So maintaining 3 sig figs, we'd have to keep all 3 of those numbers and then times 10 to the 1, 2, 3, 4. And it's a number smaller than 1, so it's a negative. So some of these examples were pretty straightforward. Some of these examples were very challenging. They made great teachable moments. That's why I picked the most challenging examples. Now it's your job to go out and practice these. I hope you guys found this helpful.